The rebuild of the Bugatti Chiron has reached a stage where it's no longer just about repairing visible damage. It's about challenging long-standing assumptions. What began as shock, they split a Bugatti, has evolved into something far more technical and far more serious. Can they bring it back to factory-level precision? The car has already been separated in half. A procedure once considered impossible outside the manufacturer's own facility has now been completed in an independent workshop. That moment proved capability. What comes next proves discipline, consistency, and long-term engineering thinking. Rebuilding a hypercar isn't dramatic in the same way tearing it apart is. Disassembly creates headlines. Reconstruction creates credibility. It's quieter, slower, more calculated. Every step forward depends on tolerances measured in millimeters, sometimes fractions of millimeters. Every component must align not just visually, but structurally and dynamically. Patience becomes more valuable than speed. The gearbox mounting bracket, the component that forced the split in the first place, isn't simply being replaced. It's being re-engineered with intent. The original cast aluminium design carried limitations tied directly to the casting process. Uniform wall thickness requirements, cooling shrinkage constraints, internal stress considerations, and compromises dictated by mass production efficiency. Casting is efficient, but it demands consistency and shape. The CNC machined replacement removes those constraints entirely. Material can now be distributed according to stress loads instead of production limitations. Reinforcement can be concentrated in high-stress zones. Non-critical mass can be reduced. The geometry can remain identical externally, while the internal strength profile improves. This isn't about redesigning the car. It's about refining a single critical point with greater control over material science. And that subtle shift changes the narrative. Because if an independent team can manufacture a structural component that meets, or even exceeds, factory strength standards, it reshapes how hypercar repair is perceived. It demonstrates that engineering capability doesn't exist exclusively inside manufacturer walls. If you respect precision engineering and want to see whether this rebuild truly meets that standard, make sure you subscribe and turn on notifications, because the stages ahead are where reputations are either confirmed or questioned. The radiators tell a similar story. At first glance, damaged cooling units on a hypercar feel irreplaceable, complex, exclusive, but strip away the branding, and they are still engineered aluminium heat exchangers. One has a visible puncture, another shows deformation. Yet both can be measured, pressure tested, and repaired by specialists who understand core construction and fin density. Mounting tabs can be replicated. Hose outlets can be aligned precisely using the undamaged unit as a master reference. This isn't improvisation. It's controlled reconstruction based on measurement, not guesswork. Every repair will be pressure tested, flow tested, and visually inspected before reinstallation. Cooling efficiency on a quad-turbo WR16 isn't optional, it's fundamental. The exhaust system is also undergoing evolution. From the factory, the Chiron is engineered to satisfy global emissions regulations, sound restrictions, and luxury expectations across multiple markets. That requires compromise. The owner of this car wants something more authentic. Not aggressive for attention, not exaggerated for spectacle, but true mechanical presence. The kind of tone that reflects 16 cylinders working under load. The entire rear exhaust assembly has been removed, carefully lowered after disconnecting electrical systems, structural fasteners, and heat shielding. It has been scanned and will be refined with engineering accuracy. Primary catalytic converters remain in place to ensure correct operation and system balance. Secondary restrictions may be revised to allow the engine's character to emerge more clearly. The objective isn't chaos, it's clarity. At the same time, custom wheels are being digitally modeled to achieve exact brake clearance. The brake calipers on a Chiron are massive, and airflow around them affects cooling performance. Even slight miscalculations in offset or spoke curvature could compromise fitment or structural integrity. Digital scanning eliminates assumption. Fitment will be verified before machining begins. And then there's the discovery that shifted the conversation entirely. The cracked gearbox mounting bracket was identified during inspection after what was primarily described as a front-end collision. Yet that bracket is located deep within the rear structure of the car. Accessing it isn't intuitive during a front-end assessment, which raises a measured question. Why inspect that specific component unless prior experience? Suggested vulnerability. If the bracket functions as a controlled failure point, absorbing energy to protect the transmission casing, that represents intelligent sacrificial engineering. Controlled breakage can prevent catastrophic drivetrain damage. But if that failure mode is known internally, then another question becomes unavoidable. If the part is designed to fail in certain impacts, and if it is replaceable, why was the entire car declared beyond saving? That question moves this story beyond mechanical repair and into philosophy. Manufacturers operate within a framework of liability, brand control, exclusivity, and residual value management. Independent builders operate within a framework of possibility and problem solving. Neither approach is emotional, but they produce very different outcomes. Right now, possibility is being tested in real time. Components are being machined from solid aluminium. Systems are being reverse engineered with deliberate measurement. Parts are traveling across borders in suitcases, not through official supply chains. The process isn't glamorous, but it is determined. Now the rebuild enters its most defining stage. Reassembly. This is where confidence must give way to precision. Wiring harnesses must be routed exactly as originally designed to prevent heat exposure or interference. Control modules must communicate seamlessly across CAN networks. Cooling systems must be vacuum-filled and pressure stabilized. The engine and gearbox must sit within precise alignment tolerances to prevent long-term vibration or uneven load distribution. Taking the car apart required courage and belief. Putting it back together demands restraint and discipline. Because at this level, mistakes don't always appear immediately. A slight misalignment may only reveal itself under sustained acceleration. A small vibration could surface at high speed. A coolant imbalance might not show until the car experiences repeated thermal cycles. That's why the real test won't be the first startup. It will be repeatability, heat cycles, road testing, data logging, monitoring temperatures, pressures, and vibration patterns, verifying that nothing shifts under load, ensuring that structural components behave exactly as intended. If the CNC machine bracket performs without flex or fatigue, if the repaired radiators maintain stable temperatures under stress, if the refined exhaust enhances character without introducing unwanted resonance, then the narrative changes permanently. This stops being viewed as a salvage rebuild. It becomes engineering validation at an independent level. And there's another layer that adds even more weight to this project. There's serious discussion about keeping the car long-term. That transforms the mindset entirely. Subscribe and turn on notifications, because the stages ahead are where reputations are either confirmed or questioned.